Hi, I'm Megan Gamendon, and I'm going to be talking about my project, Casting Out Nines with an Addition Emphasis. So here we go. I'm going to start by defining what is Casting Out Nines. So Casting Out Nines is a test that is used to check hand computations of sums, so addition, of integers to make sure that they're correct. And so comparing inputs and outputs of these digital roots help somebody to check arithmetic calculations. There's my check to prove it. And so also, even though I'm doing an addition emphasis for this Casting Out Nines problem, for my project, I also need to recognize that Casting Out Nines also applies to multiplication, subtraction, and division. But we're focusing on addition for this project. So to explain Casting Out Nines method, I decided to use an example pulled from an article called Checking It Twice, which is here, which I will cite at a later date. But the problem that it used in the article was 8,139 plus 2,648 plus 7,216 plus 3,842. And so the first thing that you need to do is you need to break down each of these numbers individually. So what you do is you add all the digits together as they are. So 8 plus 1 plus 3 plus 9, as I stated and wrote up here. And so when you add those together, 8 plus 1 plus 3 plus 9, that equals 21. And then you do the same process until you get to a single digit. So 2 plus 1, as I wrote up here, equals 3. And that's a single digit. You can't break it down anymore. So now we'll move on to the next number. Repeat the same process. You get a 2, same process, 7, same process, 8. So we broke down each of the numbers individually, and then we add each of these individual single numbers here to find that they equal 20 when adding them together. And then same process, break it down. We need one single digit. So 2 plus 0 is 2. So that's as far as we can go there. That's the singlest of singles. So we broke down each individual number for our problem here. But now we're going to add them as a whole, find their sum, and break that sum down as our check. So we'll check, boom, 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 add all those together. And we'll use our addition algorithm, which we've learned in a previous video. Go back if you need extra help. But that comes out to be 21,845. So as we did before, we'll add all the individual digits. So 2 plus 1 plus 8 plus 4 plus 5, which equals 20. Break that down. 2 plus 20 equals 2. Check, check. It's the same. And so these two single digits that we've broken them down to are check numbers. And they're equal, so we know that our sum is correct, that we've done our addition correctly. So that's how you use the algorithm. But to start to explain this and challenge the audience to know why this happens, we need to start with what we've learned first in class, which is the base 10 unit breakdown. This is absolutely essential to understanding this algorithm. So to explain, I want to start off by saying that finding the sum of the digits of the numbers is the same as finding the remainder after dividing by 9, which is why it's called Casting Out Nines, because you pull them out through division. And so we'll compare. This is the base 10 breakdown. 1, 10, 100, 1,000, keep going. Base 10, like we've learned before. And here are the multiples of 9. 1, 9, 99, 909, 999, whoo, and it keeps going like that. And so every power leaves a remainder of 1 when dividing. So 10 divided by 9, we get a 1 left over. So each one single digit is what we're working with for the check, which is what we talked about here, single digit. We broke it down to 2. So that's how the check works. That's as far as I've gotten so far. We'll be working more with this article here, checking it twice and comparing to other articles online. So that's my check video.